we're going to get into some more fun stuff. So sacred numbers that are embedded in our solar system architecture. And we start off with the sun, right? So he shows you the diameter of the sun is 864,000 miles, which means the radius is, guess what? 432 miles. Where have we seen that number come up? A whole lot. Thetas, we've seen it come up from the Sumerians, right? All as representation of these cosmological measurements. Um, and then we talk, he talked about the origin of the mile, which comes from the Latin word mil, which means 1,000, which was figured out by 1,000 paces, and that measured 5.28 feet in length. So the Romans used a mile. Stonehenge is 105.6, which is 1/50th of a mile.
Yep.
That and several other numbers found in megalithic structures of ancient civilizations give us the indication that the mile was being used as far back as 4,000 years and is still in use today. So, if we were to transition to the metric system, we would lose something very profound in the imperial system that we are currently using today in the United States. Um, Once again, like we were talking about, like I was just talking about, that 432 comes up quite a bit in these ancient cultures. 432,000 years in the Kali Yuga, 864,000 years in the Dwarpa Yuga, um, and then 2,160 years is equal to one Platonic month. So, where's that 2160 come in? Well, the radius of the moon is 1,080 miles. What is the diameter if the radius is 1,080? Well, it's 2160. So that is the amount of years in one Platonic month. So and the same number of degrees that measure the cube. So there are several examples in Sumerian text describing an arc, and this refers to the cubing of the sphere, which in this case was the moon, symbolically known as arc. Let's see. Here we start getting into some measurements of the Earth. So Earth's polar diameter, using a satellite, GRS 80, was measured at 7,899.789 miles. That's the polar diameter. The equatorial diameter, using the same satellite, is 7,926.365 miles. The diameter of the sphere with the same surface area as the Earth would be 7,920 miles. And the diameter taken through the Earth from the Tropic of Cancer to the Tropic of Capricorn is 7,920 miles. So when you look at Earth, we have a diameter of 7,920 miles. So we use 7,920 as a sacred number to represent Earth. If we took a perfect sphere that has the same surface area as the Earth and has its diameter would be 7,920, the radius is 3,960. And this will, as we go further, this will start tying together some of these ancient megalithic structures that we're talking about. Okay, so now we know some of the measurements of the Earth. From that satellite we're talking about, the GRS 80. We know kind of what to look for when we're like studying some of these ancient structures and ancient texts. So, do you know how to say this word, geodesy or geodesy?
Geodesy.
Geodesy.
No,
So,
I'm kidding.
this
It's
is the
geodesy.
determination. Geodesy. Okay, I'm stupid. I don't know. This is the determination of the size and the shape of the Earth. And it states that early in the 19th century, such knowledge was acquired by extensive land surveying over large tracts of the Earth's surface. Since the 70s, orbital satellites have provided the most accurate picture of the Earth's exact size and mass distribution. Any advanced comprehension of the larger picture of our planet as a suitable abode for the evolution of higher life requires knowledge of its size and shape. The total mass, of course, determines G, the gravitational constant. The equatorial bulge is an integral component of the forces acting to impos, impossible rotational and orbital stability on Earth as it wheels about the sun. The relevance of these two basic factors to the evolution of life cannot be underestimated.
You cannot underestimate them. You can't.
Ancient master builders understood Earth's fundamental geo geodetic parameters on a level not equaled until the advent of modern satellite surveys. Oh, how do we know that?
Look at
Well,
that. Look at that picture of this is a book I'm reading right now called The Orion Mystery. The picture of those pyramids.
mhm,
That is the layout of the constellation of Orion.
mhm.
Even the smaller star and the smaller pyramid offset to the southwest, there's something of these two things. And that was one of the things this author unveiled and had a lot of trouble getting mainstream academics to consider when he was making astronomical connections. And his whole thing was, if these match the Orion belt, then I need to assess all of the pyramids and other structures around this area, and all of those started to line up with other astronomical parts. So this whole thing is a map of that part of the sky, which is really interesting.
That is very interesting.
Yeah.
All right, so this is the Giza Plateau. I never realized, man, like how huge these pyramids must be. I bet it's a pretty impressive sight to see in person because look at how small these people are around it.
Yeah, man. Dude, I want to
That,
go, man. We need to
that's
go. We need to
that's
try to.
we need we need to go. We need to take some shrooms with us.
Hmm.
Go to the pyramids at night and just trip balls while we think about why these things were built.
Yeah.
So this is the what? How do you say this pyramid? The
Kilps. I don't know. Kilps.
Cheops pyramid. I don't know why I screenshotted that, but that's just a cool image of them. And here he's going to break down how the Great Pyramid is a scale model of the Earth at a ratio of 1 to 43,200, which is that 432 number once again.
Hmm.
So he starts off by explaining. Let's see, I don't have any notes on this.
I do. I do. And the
All right.
parallels and
So,
meridians.
all right. I'll let you pull up the image you describe. So,
Yes, yes. So, the Great Pyramid is a model of the northern hemisphere of the Earth, scaled to 1 to 43,200. The, para- the parallel meridian lines are important to understand how they work, to understand more about the pyramids. So let's cover that. The parallels are perfect circles. They go around east to west of the Earth. The meridians are not perfect circles going north and south because of the bulge. The north and south, the meridians are more of an oval. So as you're moving toward the North Pole, the Earth is actually flattening. So you have to travel further to traverse a degree of arc the closer you get to the North Pole. So the meridian line from 0 to 1 degrees, starting from the equator going up, is 68.703 miles. When you get to the 89th to 90th degree, it's 69.407 miles. So it gets a little longer. Not much, you know. And the parallel at the equator is 69.172 miles around. At 45 degrees up halfway, it's 48.99 miles around. And at the 89-degree mark, way up there, it's only 1.21 miles around. So what's important is the Earth's measurements will vary depending on where on the Earth those measurements are being made. The ancients knew this and incorporated it into their architecture. Their units of measurement were derived on the shape of the Earth, specifically where the structure was being built on the Earth. That's what's important. So these notes jump to.
I'm just showing the images to kind of go along with it. So you describe the here we have All right. The distance between two meridian lines at the equator will be a greater distance apart than two meridian lines at the North Pole due to the shape of the Earth and the bulging effect. It gives us the orbital stability. This shows just like a top-down view from the North Pole of you have your parallel lines, which are perfect circles, but then you have your meridian lines as well, which are the lines um, coming basically from the outer edge of the circle towards the center, making a radius more or less. This is just a table of from the Smithsonian of the length of degrees, the length of 1 degree at the meridian, and then 1 degree of the meridian at the equator is 68.703 miles. And then when we get up to the North Pole, it's 69.407 miles. Then we have the length of 1 degree of the parallel, which is 69.172. So 1 degree of latitude at 89 degrees is 1.21 miles, which is right up here at the top.
Yeah.
1 degree of latitude at 45 degrees is equal to 48.99 miles. So we're right there. And 1 degree of latitude at 0 degrees is 69.172 miles.
Yeah.
So as you're stating, all of this is conveying that if we're trying to measure the size of the Earth, where we are on Earth is important because it's going to vary.
Yeah, if
Ancient
you
people knew this and
like the little
incorporated it.
square, the square of
Yeah.
the meridian and the parallel, those lines that make the squares are different all over. So the
So
pyramid,
for somehow the ancient people knew this when they were building their architecture and incorporated it into the architecture. Did they derive the units of measurement that were ultimately based on the size and shape of the Earth and where the structure was being built?
yeah,
Um,
and that goes for the Parthenon. That goes for multiple ones. So I'm gonna read through these notes I took on that,
yeah.
and I'm just gonna read through because it's kind of hard to remember. I'm just gonna read through. So there's a random part about the Sphinx in the middle, but this is interesting. It would connect. So the Sphinx, um, minimum of 20,000 years needed to show the water erosion. The Sphinx has water erosion on it. So, according to the calculations, it would take 20,000 years of consistent water flow to make the same erosion that we see on the Sphinx. So, it would require a climate with a rainfall of 45 inches a year. The Sphinx is traditionally said to be 4,000 years old. In that 4,000 year span, there's been no rain in the desert. So the real date of the Sphinx is tens of thousands of years older because they said that it was sand erosion, is the mainstream claim. Sand erosion that eroded the Sphinx, wind and sand blowing it, blah, 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 blah. But sand erodes differently. It causes pits in the rocks. And there's no pits on the Sphinx, it's water erosion. So there's a difference there. Which brings up the question as to how old the pyramids really are, because the traditional claim is that they belong to Cheops or Cheops, were built. The original claim they belonged to Cheops, but were built by Snefru, his father or something, in the fourth dynasty. That's still not fact. It's based on inscriptions that were found inside one of those pyramids 1,200 years after the supposed building date. So, like at the beginning of the fifth dynasty, someone inscribed something in there saying it belonged to Cheops, and that's the mainstream claim that they were belonging to this guy. There's really still no evidence they belong to him. So that's what I was saying earlier about how the mainstream science and evidence is as true as the alternative, and the alternative is actually more true because it's actually considering the evidence there.
Yeah.
So the pyramids were encased in a white stone and they've been stripped off. It shows the limestone underneath. So the original casing stone at the base of the pyramid was at 51 degrees. So they can find the original slope and height of the pyramid, that outer layer. The socle is like a little platform under the pyramid. You can
Right
count the
here.
socle or not. Yeah, there you go. That red thing is the socle. The base that the stone sits on, the foundation, is 1 cubit or 20.8 inches out and 55 inches thick and sits directly on the bedrock. You can measure the height of the pyramid with or without the socle. So, let me go through those measurements. The perimeter, not including the socle, is 756.081 feet on the south side. The east side is 755.874 feet. The north side is 755.421 feet, and the west is 755.763 feet. A total of 3,023.139 feet. With the socle, the south side is 760.783 feet, east side is 760.900 feet, north side is 760.817 feet, the west side is 759.933 feet, a total of 3,043.433. Measured on top of the socle, it comes to 7/11, a ratio of 7 to 11. Including the socle, it's 481 feet high. So the polar radius is 13 miles short of, what is this, the Earth? Equatorial circle of the Earth. Oh, the polar radius is 13 miles shorter than the equatorial radius. A degree on the equator is longer than the Meridian. Okay, so here we go. At the equator, 1 square degree measures 69.171 miles along the parallel. And from the equator up 1 square degree on the meridian measures 68.7031 miles. 1 square degree on the parallel divided by 60 will give you 1 square minute of latitude and longitude. 1 square minute divided, 1 square minute at the equator or latitude east and west. Yeah, 1 square minute is 6,087.0941 feet. And 1 square minute of longitude north and south at the meridian is 6,045 feet, 0.881. 6,045.881 feet. So if you divide the square minutes by 2, total of 4 1/4 sections, and the latitude east and west is 3,043.547 feet, and longitude north and south is 3,022.940 feet. Total perimeter of the Great Pyramid, not including the socle, is 3,043.433 feet. And the total perimeter, including the socle, equals 3,023.139 feet. So that's how the meridian and longitude comes into play, because if you divide the meridian measurement of 68.731 miles and the parallel measurement of 69.171, if you divide that by 60 to get a minute of arc, then you're left with those number of feet. And then if you divide those by 2, you get the measure of the perimeter of the pyramid. So their fractal nature of their position on the Earth, it's a parallel meridians. And if you take the height of the pyramid, including the socle, 482.7575 feet times 43,200, its scale size relative to the northern hemisphere of the Earth, you get 20,855,124, or 3,949.834 miles. The World Grid Survey of 1972 polar radius of the Earth is 3,949.8934 miles. So these motherfuckers encoded the shape of the Earth, including its bulge, and
in the pyramids.
Into the pyramids. So
the Great Pyramid.
Yeah, so this is the really interesting part right here about the pyramids and the meridian and longitude and all that. So every half second, the Earth turns. Every half second, the Earth turns. The Earth will turn the distance equal to one side of the base of the Great Pyramid, measured with the socle. This half second is 1/172,800th part of the diurnal rotation, as it's called. 1/43,200th part of the diurnal rotation is 2 seconds of a spin. In this 2 seconds, the Earth spins the distance equal to the total perimeter of the pyramid measured with the socle, and that's specific to its position on the Earth, meridian and parallel, longitude and latitude. Does that make any sense?
It did.
It's a lot of like large numbers, but basically every 2 seconds the Earth spins the distance of the perimeter of the pyramids, more specifically relative to where it is on the Earth with the latitude and longitude, because the other pyramids are kind of measured the same. The
And I
height of
know
the
we just went through. Go no, go ahead.
pyramid is 482.75. I said that the pyramid's height relative to its base is equal to the radius of a circle to its circumference. Pyramids are the solution to the squaring of the circle. The base of the pyramid's surface area is equal to the circumference of its square. The square of that circle is equal to the area of the Earth's base.